Hi, welcome to the Finchley College. This is a video for coordinate system. I'd like to introduce you the national grid and the local grid and converting from one system to another system. The coordinate system, before I start that, is two lines at right angle. So this is 90 degrees. The north is in that direction, minus north this direction, east is to the right, and minus east to the left. So we don't have south and west, we just have plus north, plus east, minus east. The units are in meter, in this case is 0. 0 is the origin, the intersection is easting 0, northing 0, and height 0. Then as you move to the right, the easting increases by 1 meter, 2 meter, 3 meter, 4 meter. If you move to the left, you go minus 1, minus 2, minus 3. If you move forward, plus 1, plus 2, plus 3. If you move backward, minus 1. Now this grid is on the floor, is on the plane. It's not vertical as I've drawn it in here, it's actually on the floor. So you may be standing here, for example. If I was standing here, for example, my easting will be, if I draw a right angle to here, will be like 4.6. So that easting is plus 4.6 meters. And if I draw a right angle to north axis, my northing is about 3.5 meters. So the coordinates are there. If you draw a right angle to each axis and you measure the dimension from the origin, this is your easting, which is between 4 and 5, and this is your northing, which is between 3 and 4. So the coordinate is a distance along the axis from the origin to the point. If I was in this coordinate here, for example, if I was here, my easting would be plus 3 meters, and my northing will be minus 4 meters. If I was here, my easting will be minus 3, and northing will be minus 2. For example, here, easting is minus 2.5, and the northing is minus 2 meters, etc. In this one, the easting is minus, and the northing is plus. Now, in surveying, we never use a negative coordinate. We always have positive coordinates. Therefore, we will avoid using these three quadrants. Or system or surveying, everything will be in quadrant 1, Q1. Quadrant 1, this is where we do all the surveying and setting out. Our project will be here, and the map of UK, as I said, I've drawn a rough crude map of UK. The origin in this case is in the sea, is to the left, well away from the land, so that the entire land mass and even the islands here and here on the side will be in quadrant 1. The units for the national grid is 100 kilometers. So they go, so every line is 100, 200, 300 kilometers. That's 100,000 meters, 200,000, 300,000. If we think of London, London is approximately 500,000 meters from the origin, and the northing is about 185,000 meters from the origin. This means that a national grid coordinate has got 6 digits of meters and 3 digits of millimeters. So the total digits is 9. 9. There are 9 digits, 6 units meters and 3 millimeters. Now, we have a local coordinate system. Why do we want a local coordinate system? Imagine that you go on a building site and you've been given a drawing which has got grid lines A, B, C, D, 1, 2, 3, 4. And the architect has indicated that this point and this point have these coordinates, which is national grids, 520,184, 185,362, 520,199, 185,388. Now, in this coordinate system, if you consider 2 points, if I had another point here with the same easting, the easting for this will be the same, 4.6, but the northing, say, will be 1.5 meters. Now these two are 2 points on the same line. If 2 points have the same easting, that means they are the same distance from the north axis. This is 4.6, this is 4.6. Therefore, this is a vertical line parallel to the north axis. If 2 points had the same northing, like a point in here, if I put another point in here, with the same northing as -4, 2 points with the same northing, that means this is a horizontal line parallel to the east axis. So what the coordinates are telling you is that where you are in this system, how far you are from the origin. If 2 points have the same easting, that's a vertical line. If 2 points have the same northing, then they are horizontal line parallel to the axis. So the coordinates will tell us, looking at the coordinates of 2 points, we can find a relationship between those 2 points. So when we go to the construction site, we've got a drawing, and we see that the architect has indicated the grid intersection of grid line C1 is this value, and grid line C4 has this value. We look and see that the eastings are not the same. Easting is 199, easting is 184 here. That means this point is a bit closer to the axis than this one. There are 520,184 meters from the origin. This one is 520,199. It's a bit further away. What does that mean? That means the axis is pointing this way, and the 2 points, one is here, one is here. This distance is slightly shorter than this distance. Remember, we always draw at right angle to the axis. That is how we calculate the coordinate. What the coordinate means is the distance. If you draw a line at right angle to the axis, that's it is. So this means when I see this coordinate, because this is bigger than that, this one is further away from the axis, therefore the axis is like this. That means that the north axis is not parallel to the grid system. Now, I don't like that. I like my north to be parallel. So what I want to create a new north like this. Let me put it this way. For example, I want to create a new north plus east. This new axis is nice and parallel. Because why? Because I've said, let's assume this grid line A is 200 meters, just a meter here, from this axis. Then B, I've assumed that grid between each, dimensions between each grid is exactly 10, just to make it simpler. So grid line B is more to the right, so therefore grid line B, if that's 200 from here, and this is 10 meters, that will be 210 meters from the grid. This is 10 meters further away to the right, therefore grid line C will have an easting of 220. Grid line D will have an easting of 230. Now for the northing, I'm going to assume that this dimension is, say, 500 meters. If this is the 0, easting 0, northing 0, height 0, this northing is 500 meters, this one will be 510, 520, 530. So now from here, I have a coordinate for every grid. This point has an easting of 210 and a northing of 520. This point has an easting 200 and a northing of 510. So I write the easting first, usually the northing next. You can write it vertically like that, or you can write like that, easting 200, northing 510. Easting, northing. or easting, northing. By convention, in UK, we write easting first, northing second. So, what I like to find out, I've created my own coordinate system in a way that the north is parallel to the grid lines. But what I need to do now, okay, what do I do with this? How do I convert from this to this? On the construction side, I've got two controls. I've got a control 1 and I've got a control 2. Control 1, architect, I've got on site. When I go to the site, they give me these coordinates based on the national grid. I've got my own coordinates. I need to find out what is the coordinates for this one in local, what is the coordinate for this in local. The way to do that is to use a programmable calculator or a spreadsheet. To do the conversion, to find the coordinates of control, convert them from global to local, you need to have the coordinates for 2 points that you know in both global and local. In this case, I use these 2 because it's given. On the drawing, this is given at this, and this is given at this. I know my own these coordinates because I've just created my own system. This one is 220, northing 530. This one is easting 220, northing 500. So for these 2 grid intersection of C1 and C4, C4 global, all right, here C4 global and C4 local. So this is G for global and this is L for local. G for global, L for local. C1L. What do? We've got a programmable calculator, or we've got a spreadsheet on our website that you can go and download for coordinate transformation. You need to enter the coordinates of the 2 points in both global and local. And then if you put the local first, global first and then the local next, when you enter this global, you can convert to local and you can get these coordinates. So you put this one first, C1 global, C4 global, then you enter C1 local, C4 local. From that system, when you enter this, the program will give you this result. When you enter this point, the program will give you this result. And that's all you need to do. Essentially, you're finished with the global system. You have your own local system where the north is parallel to the grid, because every point along this grid has the same easting, 200, 200, 200, 200. This one, 210, 220. Every point along here has the same easting. Every point along here has the same northing, 510, 510, 510, 510, 510. So that's all you have to do. When you go to a construction site and they give you a drawing, grid line A, B, C, D, grid line 1, 2, 3, 4. You look at the grid and you say, oh, I've been given a coordinate for a grid intersection, 2, 3, 4 grid intersections. You select 2 along the same line, perhaps, and you can look and you can see the eastings are not the same. Therefore, my north is this way or this way. Then you create your own system. You say, let grid line A has an easting of 200 meters, say. Therefore, B is 10 meters to the right, easting will be 210, 220, 230. I'm going to assume the bottom grid on the first grid on the bottom is 500 meters from the new axis. Therefore, this one will be 510, 520, 530. So now I know the coordinate in my own system for every grid intersection. I select 2, ideally as far apart as possible, like this one and this one, that is longer than that. I put that one in the coordinate calculator, that one in the coordinate calculator, these 2 as their local equivalent. Then when I put a third point in global, the program will give me local. If I had entered the local first and the global second, and when I put the local in coordinate, the program will convert to global. So that is the essentials of coordinate system. You have a national grid coordinate system, whereas the origin is in the sea and the typical coordinates are 9 digits. Alternatively, you have got your own local system, which you take the grid and you set your own coordinate system. Now, I want to talk to you about local coordinate system for setting out and for surveying. They are a bit different. Okay, so in the case of the local coordinate system for setting out, you already have a drawing, you already have grid lines, and you've already got coordinates in global, you created your local, and then what you want to do is to convert existing site control from the global system to your own local system. Now we have another local system for surveying. In the surveying, what happens, for example, imagine you have this car park. I have this car park, for example, and they've asked me, can you survey this car park? And I come in here and there is no control whatsoever. There is nothing. So what I decide, first decision I have to make, I will go and fix some of the retro targets in various places on the walls for future use. I'll call this, for example, retro 1, retro 2, retro 3, retro 4, retro 5, retro 6. So I've got these retros, they're square and with a cross in the middle. Now I set up my total station anywhere on site, and I want to decide where the north is going to be for this survey. I can decide the north to be in this direction, or the north to be in this. North is 0, but the angle, horizontal angle is 0. Or this direction, or the north to be in this direction, or any direction I want. For example, I want to set the north in this direction. Imagine that I want the north in this direction. So I can use a program called local resection on a TS 06 plus total station, Leica total station. I go to local resection, and what I need to do is to site to a point, any point here. This is point 1. Then I'll site to a second point here. This is point 2. First point is going to be origin. So this point is going to have a coordinate easting 0, northing 0, height 0. This point is going to establish the north direction. So when I say this is the point, the north is going to be that way. If I select here, then the north is going to be this way. So if I wanted the north that way, I would select a point here, 1, and point here, 2. If I wanted the north this way, I would select a point here, 1, point 2. Point 1 is going to be the origin, point 2 is going to be the north. And that's it. That's all you have to do. And then what the total station will work out is position in relation to this system. So in this case, because it's to the left of the north, its easting is going to be negative, is going to be here. And this distance, say for example, 4 meters. And its northing is how far it's from there to here. For example, this is 1 meter from the origin. So it's 1 meter along the north and -4 to the left. So it's going to say my easting is -4, my northing is +1. And the height is depending the height of the instrument. But we don't want a negative coordinate, and we don't want our origin to be all on site. We never have the origin on the site. So then we change the station, we go to quick survey program, we change the station coordinate, we say let this be 200 and let this be north in 500. The north is still in the same direction, but we change our station coordinate. So now essentially we now have a new system, and at this point we survey the retros and we record the coordinate east, north, east, north. We record the coordinates of each retro, and future when we come back on site, we do normal resection to work out the instrument position. So the difference between local coordinate for surveying and setting out is that in the first system, we have a drawing, we have controls already established on site, we have coordinates given on drawing based on global system, and we create our own new axis, which is parallel to the grid lines. In this one, our new axis is parallel to a feature. It could be a wall, it could be a parking bay, it could be anything. And we make it parallel to that. How we do it is by site first point to any point. Doesn't need to be in the corner, it can be any point. Second point further away in the direction we want the north to be. And that's how we create a local coordinate system for surveying. Thank you very much.